spaces. So one of the main things that we do in chapter 4 is we prove that two triangles are congruent. Okay, so you're going to be given a figure or a shape or a drawing, and you're going to be asked to actually prove through statements and reasons, through two-column proof, that two triangles are congruent. Okay, there are 5 ways that we could do this actually. All right, I'm going to show you 3 of them right now and then 2 of them later. All right, the first one is called SSS postulate. All right, this is the very first one. You're going to have 5 tools in your arsenal. Thank you. 5 tools in your arsenal. All right, you get to try to figure out which one to use before you start the proof. This is the first one. It's called SSS. You know what SSS stands for? It's called the side postulate. Okay? So here is the if-then statement for side postulate. Here's what it says. If, you know this, if all 3 sides of one triangle are congruent to all 3 sides of another triangle, then what do you think you can say? If all 3 sides of one triangle are congruent to all 3 sides of a different triangle, what can you conclude? Then the 2 triangles are congruent. Okay? This is the very first way to show that 2 triangles are congruent. It's called the SSS, or side postulate. Okay, so take a look at this picture. Do I have, those are sides, right? We'll call these 14 inches, 11 inches, and then 15 inches, okay? So the question is, do I have enough information right now to say that this blue triangle is congruent to this green triangle? Do I have enough information to say that? Yes. And the answer is yes, I do. Because right here, this postulate says if all 3 sides of one triangle are congruent to all 3 sides of another triangle, then the 2 triangles are congruent. So this is by side. So I would take a look at this and say, okay, this is a side, that's a side, this is a side, that's a side over there, and this is a side, and that's a side. And if all 3 sides are congruent, then it must be true that the triangles themselves are congruent to each other. Okay, so here is the thought process, and we want to model what you should be thinking when you are asked to prove 2 triangles are congruent. So whenever you see this, whenever you are asked to prove that 2 triangles are congruent, there's going to be 5 ways that you're going to try and do it. In this particular case, I've only given you 1, and what way is that? Side. That's all we have so far. We're going to have more by the end of the day, but right now all we have is side. So here's what we're going to do. We're going to take the information that we know, and we're going to dress up our picture. Okay, so tell me something that I know. What's been given to me?
AD is congruent to CD.
Adrian, awesome. AD is congruent to what? CD. So I'm going to mark up my picture just like that. AD congruent to CD, okay? And I'm going to say that right there is a side, isn't it? That's the side of a triangle. You guys read? It's either a side or an angle. This one's a side, okay? What else do I know? AB is congruent to what? CB. Okay, and what is that? Is that a side or is that an angle? That's a side, and that's a side. So far, how many sides do I have?
4.
Whoa, what? No. Sorry. 2 on each triangle is what I meant. Okay, I see why you guys said 4. That makes total sense. But I have 2 on each triangle, right? I have a side and a side on one triangle, and I have a side and a side on another triangle, right? Because I want to show, I'm trying to prove that triangle ABD, so this blue one here, okay, I'm trying to prove that this triangle is congruent to what triangle, you guys? This one down here, this yellow one. So far, I have that they each have 2 sides to congruent. Now, where is that 3rd side going to come from? The common side. Yes, very good. So this will be in green right here. So check this out, right there, that one. And that is what? That is considered to be a side. Okay, and they share that one. So it looks to me like I have side. So how do we do this in a proof? Okay, well, here's how I want you to do it in the proof. Well, first of all, we get our easy points. Okay, number one, we say that AD is congruent to CD, and we label that in the proof. Okay, this is something extra that I teach all my students because I want you to see how the structure comes out. That's a side. We're saying that that particular side is congruent. Okay, and then what's the other side that we're saying? We're saying that AB is congruent to what? CB. That's also a side, and all of this stuff has been given to us. Okay, so both of those things have been given, and so far I've shown two sides. So if my plan is side, 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 what's the next thing I'm going to try and look for? The third side. So step number 2, what could I say? DB is congruent to what? To DB. And what is that? Is that a side or an angle? Well, hold on. Is that a side or an angle? It's a side. I want it in the proof. Okay, I want these things right here in these little brackets so you know what you're looking for. Okay? And the reason this is true, you guys, is because it's reflexive, absolutely. Okay, now take a look at your proof. You have an S, an S, and an S. That's when you know your proof is over. See how this works? So now triangle ABD has to be congruent to triangle CBD. And what's the reason we can say this, you guys? Because it's right there. The side, side, side postulate. Alright, you guys ready? So the next one in our arsenal of proving that two triangles are congruent is the side angle side postulate, and it says this: if two sides and the included angle, this is the important part, the included angle of a triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So, two triangles are congruent. Another way to do it is by side angle side. What do I mean by this word here? Included. Included. What do you think I mean by that?
Like what it's given.
No, it's included between the two sides. So do you notice here? Here's the part that's interesting, okay? Do you see how it goes side and then angle and then a side? How the angle is between two sides? Do you see that? So it has to be a vertex angle, right? Very good. It has to be a vertex angle. So here's what I mean. Here's some examples of what it means to be side angle side, okay? Let me give you this one. I give you that one, and that one. That is side angle side. Do you guys see that one?
They all be included then if it's vertex?
The angle has to be between the two sides. That's side angle side. Here's an example. Here's an example of something that's not side angle side.
You had both of them on like
Okay.
opposite sides, like the two marks on opposite sides.
The angle has to be between them.
Okay.
The one on the right here, this one, this is not side angle side. Okay? This is angle side side. You see how the order matters? Or side side angle, however you look at it, right? So this is not side angle side. This one is side angle side. Do you see the difference between the two? So the angle has to be between the two sides. That's what the word included means. It has to be in between them. Do you see the difference? Okay, that's very. Taking a look at this one here, do you think this one's going to be side, 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 or side angle side? Well, let's take a look and see what we have, all right? What do we know? We know that E is the midpoint of MJ. So if E is the midpoint of MJ, what do we know? What does that tell us? That tells us something. What do you think? Yeah, you said. Not midpoint. No, that's not what it tells us. Yes. Not M and J are the same. No, yeah, Juliana. Yeah, it tells us that this segment, ME, has to be congruent to what? EJ, because that's the definition of midpoint. And check it out. That's a side. Do you guys agree with that? That's a side there, and that's a side there. Okay, so so far I have a side on each triangle, right? I'm trying to show, I also like to color them in. I'm trying to show that the yellow triangle here is congruent to the blue triangle over here. That's what I'm trying to show. And so far I have a side for each one. Okay, what else do I know? What else have I been given here? In blue.
T
TE is perpendicular to MJ. So TE perpendicular to MJ. So that means that there's a right angle there. Is that true? If there's a right angle there, then where else is there a right angle?
Right next to it.
Yeah, there has to be a right angle over there and then down there, okay? So is that an angle or is there a side?
That's an angle.
That's an angle. I have an angle there and I have an angle there. Good. So far I have a side and I have an angle. It would be nice if I could get the included side in between there, right? So what could I say?
Wait, don't we? Oh, never mind.
So far all I have is a side and an angle.
The midpoint would be the common side.
The common side. Which one's the common side? TE, the common side. So like this one right here, right? This was highlighted pink one. Obviously has to be congruent to itself, and that right there is a side. So you guys tell me, what's the plan going to be for this one? Side angle side. There you go. Nope, doesn't say that. Well, I mean, for CPCTC, yeah, it's going to be, but for right now, we don't need that, right? We're trying to prove that the two triangles are congruent, and we're going to prove it using side angle side. That's going to be our plan. So now that we have a plan, we're going to execute that plan. So here we go. Number one, I want to actually prove this by going side angle side. So what could I say here first? The given, right? Okay, so what do I know?
E is the midpoint.
Okay, there you go. E is midpoint of MJ. And what else do I know?
Perpendicular TE.
TE is perpendicular to MJ, and all of that is given. Okay? But does that prove anything yet in terms of a side angle or a side?
No.
No. So what's my next statement going to be? There you go. ME is congruent to what?
Wait, TE and MJ. The ME is given to EJ.
You're right. I didn't mean to number that differently. Okay. So I have ME congruent to what? And that's a what? A side or an angle?
That's the side.
That's a side. And why is that true?
That's the definition of it.
Because it's the definition of a midpoint. Very good. Okay, so far I have a side, and my plan is side angle side. So I need to get the angle and then the other side, right? Okay, good. So let's get the angle. What can I say?
You could say,
What was it? We could say perpendicular or right angles.
or
Yeah.
TE is perpendicular to MJ.
We did that. We said that TE. That's in step 2. It's given. So what does that mean? There you go. You can say angle MET is congruent to what?
TEJ.
No. How did I label it? MET congruent to JET. Okay. And that's an angle, right? Yeah. So here we go. Number 5. What's the next thing I can say? What do I have so far, you guys? I have the side, then I have the angle. What am I looking for? I'm looking for the side. So what are we going to say?
TE is congruent to TE.
Okay, there's the picture. I'm looking for the common side. So side TE
Oh yeah, it's congruent to side.
is congruent to side. Oh shoot. Side TE, right?
That's reflexive.
And that's a side, and that's reflexive.
Maybe ET. Is it step 4 though? What we're trying to prove?
All right. So what do we have? What have we shown you guys?
You can say
There you go. There's sass in there. Right? There you go. So therefore, triangle MET is congruent to triangle JET by what?
SAS.
By side angle side postulate. There. All right. So you guys predicted it. You predicted it totally correct. If two angles and the included side of one triangle congruent to two angles and the included side of another triangle, then it must be the case that the two triangles are indeed congruent. So I'm going to give you a picture of what this would look like for angle side angle. So here's a picture, here's a triangle, and then here's another triangle, okay? If this is my angle, that's my side, and that's my angle over there. That's angle side angle. You guys get it? That's what angle side angle looks like. So that would be congruent to this one, angle, and then a side, and then an angle. You've got to make sure that the side is in between the two angles that you're trying to show. That angle, that angle, that angle, and that angle. That's the picture for angle side angle.